Hello everyone, welcome back to the channel. So today is fourth and second last session of statistics, which carries 2 marks as per IBBI syllabus, and also second last session of whole IBBI syllabus. In current session, we will try to cover basic concepts of these topics, which is assigning probability, basic laws of probability, probability distribution, DRV, discrete random variable, CRV, continuous random variable, binomial probability distribution, Poisson probability, normal distribution, sampling distribution, parameter distribution, confidence level. We'll try to cover from IBBI exam perspective because this topic is very vast. Again, I said since it carries only 2 marks, so we'll try to cover areas or concepts out of which IBBI may ask a question from these topics. So in session number 1, we have already covered this part of the syllabus. Second session we covered central tendency, and third session we already covered dispersion and skewness. If you have not seen this session, please go through them. Otherwise, there is no point in going through this fourth session because there are many concepts which we are using out of these 3 sessions into current session. So what is probability? Probability is a numerical measure of the likelihood that an associated with an event. Probability is number range. It is nothing but a number range from 0 to 1, or maybe in percentage 0% to 100%. So 0 probability means the event is unlikely to happen, and 1 probability means the event is almost certainly going to be happen. How to calculate probability? One of the approaches to calculate or define probability is the experimented approach, which is based on doing an experiment and possible outcomes of that experiment. So experiment is nothing but the process that generates well-defined outcomes. So we do experiment and some outcome comes out of it. So on any single repetition of an experiment, only one possible outcome will occur. One experiment will give one outcome. That is an experiment. And sample space is possible outcomes of all experiments. Set of all possible outcomes of doing an experiment. And each experimental outcome which is possible out of each experiment is called sample point. So let us understand this experiment, sample space and sample point with the help of few examples. Let us say we take a coin and toss it. What are the possible outcomes? Either we'll get head or tail. So sample points are, experiment is tossing a coin, and sample points are head, this is first sample point, and tail, this is second sample point. And possible space is this combined, this sample space. So if we do experiment of rolling a dice, then 1, 2, 3, 4, 5, 6, each of them is a sample point, and this combined data is sample space, and this is the experiment. Result of a cricket match: win, lose or tie. Sample point, win, lose, tie individually, and combined data is sample space. Measure the height of any student in your class. Set of numbers representing height of each student. Approaches of assigning probabilities. So there are 3 basic approaches. Once all experimental outcome or sample space are known, probability of each outcome need to be calculated. When sample space is finite, probability of each outcome can be calculated using any one of these following approaches. So if we have a finite data, then any of these approaches can be used to calculate probability of any sample, probability of getting any one outcome or any one sample point, say EI. Classic approach, relative frequency approach, and subjective method approach. Let us understand each one of them one by one. Classic approach is nothing This method is used when all outcomes are equal likely and hence probability to each outcome must be same. Like we are tossing a coin, so head or tail, both are equal. So probability of getting head or tail is 50%. So here sample space is head toss, head or tail, and probability of getting any one event is 1 by n divided by 2. This 1 by 2 is 50%. Right? This is the formula. Simple. Important word is probability, possibility equal, like getting outcome, each outcome is equal. Each outcome is likely to be come out equally. Let us understand this approach with the help of an example. If we roll a fair dice, then probability of what is the probability of getting head and tail? So here sample space is head and tail. Probability of getting head is PH 1 by 2, 50%, and tail again 50%. Relative frequency method. This method is used when data are available to estimate the proportion of times the experimental outcome will occur. If the experiment is repeated large number of times, so if we do a number of experiments and we have a substantial data for that, then relative frequency method can be used to calculate probability of getting a specific outcome with the help of this formula. So number of times that outcome occur as per data and total number of times the experiment was repeated. Say we rolled twice, we rolled our dice and say 100 times and we get two number 40 times out of 100. So that means possibility of getting 2 is 40%. 40 divided by 100. Let us understand with the help of an example. A toothpaste manufacturing company is studying 5 different package designs. In an actual experiment, 100 consumers were asked to pick up the design that they preferred. The following data were obtained. So this experiment was repeated with 100 consumers. Company launched 5 packages and gave those packages to 100 consumers, and it observed which consumer liked which design. So first design was preferred by 5 consumers. Second design was preferred by 15. Third was 30. Fourth was 50, and fifth was 10. So 10 consumers like fifth package. So let us assign probability to each of the 5 designs. So design number 1, 5 people like out of 100. So probability is 5 divided by 100, that is 5% or 0.05. So likewise for fourth design, 40 people like out of 100. So 40 divided by 100 is 40%. So it is like we can calculate probability of each of these design. Probability of selecting each design basis this last data. Subjective method. This method is used when experimental outcome cannot be judged to be equally likely and little relevant data is available. So possibility of getting all outcome is not equal likely and we don't have much data like in second method. Hence any other information available such as previous experiment etc. can be used to assign the probability. So degree of belief on the basis of available information that a specific event will occur. It is subjective and depends on person who is assigning the probability. Different person may assign different probability to same occurrence. So that means we are assigning probability of those 5 designs. We don't have adequate data for that, but we have done similar experiment in past. So we have the past similar experiment data with us, and based on that data or perception, the person who is calculating the probability will assign probability to each event. So it is subjective. You may give different probability to a particular event based on your own personal experiences, personal database. I may give a different probability for same event. It's highly subjective. There is no formula. So whether it will rain on a cloudy day or not? What is the probability? Say, somebody will ask a question to you, whether it will rain today or not. So two outcomes are possible. It will rain, yes. It will not rain, no. Relevant data may or may not be available. A well-experienced person in the region can predict the chances of rain, which in turn will assign probability to these outcomes. So one specialist may say 50% chances, other specialist may say 55% chances. So that is based on their experience. Basic laws of probability. There are basically four basic laws of probability: complement of an event, union of two events, law of addition, intersection of two events. These four laws are also important from exam perspective. Complement of an event. So if say we have A is an event of a sample space S. We have a big sample space which is A and one of the event is A. Then AC is complement event of A. AC is a symbol for complement event of A. So it will contain all sample points of the full sample space which are not covered in A. So graphical presentation, like, so this green bubble is full sample space. So if this is the A event, probability of getting A is this, right? So complement to it, complement event is remaining part of that. So if you have given probability for A is say 20%, and examiner is asking you what is the probability of complement event of A, then it is 1 minus 20% is equal to 80%. Let us understand this with the help of an example. Say this is the sample space of a dice 1, 2, 3, 4, 5, 6, and A is set of 2, 4, 6, getting even number. Then complement is 1, 1, 3, 5, getting odd number. So that means probability of getting A even number or probability of getting odd number is 1. Well, that is 1, 2, 3, 4, 5, 6. Either we will get an even number or an odd number. Union of two events. Union of two events A and B is denoted by AUB, A union B, and contains sample point that belong to A or B or both. So if this is event A and this is event B, so union means this area which is specific to A, this area which is specific to B, and this combined area which is common between A and B. This total area is equal to A plus B. Law of addition. If A plus B is equal to probability A plus probability B minus probability of A intersection B. So basically this area plus this area minus this area. Why minus? Because this area has been added twice from this and this. So you have to minus it once so that we will get area, total area for this diagram picture. Getting probability with the help of diagram is always easy. If you get a question of getting probability, it's very easy to draw a diagram and calculate it. It's convenient. Intersection of two events. In case of mutually exclusive events, intersection of like A and B, they are mutually exclusive. Then P intersection B is infinite. Right? In that case, P intersection B is 0. That means infinite means 0. There is no intersection area between them. So that means P union B is equal to P plus PA, and probability of getting event A plus probability of getting B. So if examiner gives you, ask you to ask like a PUA probability, like combined probability of happening of event A and B, and both are mutually exclusive events, then you have to add these two simply. This is the example to understand this concept. In a fair playing card game, what is the probability of getting an ace in a single trial? There exist 52 cards. There are 52 cards in a card game. Out of these, there exist 4 aces, 4 ace cards. Thus, probability of getting an ace in a single trial is nothing but 4 aces divided by 52 cards. There is 1 by 13. Find out the probability of getting 53 Sundays in a leap year. A leap year has 366 days, that is 52 weeks and 2 days. Since each year shall have mandatory 52 Sundays, if we get Sunday on any of the remaining 2 days, the leap year shall have 53 days. So we have to calculate probability of getting Sunday on these 2 remaining days. So what is the probability? Because there are 7 days in a week and 2 days, if it is Sunday, then 2 days divided by 7 is equal to 2 by 7.286 is the probability. Find out probability of getting a sum of 9 on top of 2 dice thrown together. If we throw 2 dice together, so maximum score we can get is 12 and minimum score we can get 2. Since each dice has 6 sides, 1 to 6, we can get 36 combinations if we threw two dice. Thus total sample space is 36. So this is a total possible outcomes. And if we want to have a score of 9, then there are 4 possible outcomes: 6 plus 3, 3 plus 6, 5 plus 4 and 4 plus 5. If we get any of these 4 outcomes on 2 dice combination, then we will get sum of 9. So probability of getting sum 9 is this number 4 divided by total possible outcome. Sample space 36 is 4 divided by 36.111, 11.1%. Let us talk about probability distributions. Random variable is a numerical of an experimental outcome possible out of sample space. So random variable can be of 2 types: discrete random variable and continuous random variable. Discrete random variable has a countable number of possible values. For example, the month on which a person is born in DRV, which has values 1, 2, 3, 4, like 99, 100, right? So it has a countable number of possible values. So it can be finite or infinite. So finite discrete random variable is x1, x2. So we know last entry on the number. And here we do not know the last. It's infinite. There is no end to it. And it is a countable number of possible values. DRV, discrete random variable, means countable number. DRV has following 2 characteristics. Probability of each DRV lies between 1 to 1, 0 to 1. So 0% or 100%. Probability of each discrete random variable will be either minimum 0 or maximum 100, or maybe in between of them. Sum of probabilities of all DRVs is always 1 or 100%. That is second characteristic you should remember. The following data was collected by counting the number of operating rooms in use at Sayaji General Hospital in the month of June 2022. So number of operating rooms in use, 1, 2, 3, 4. So this is the number of room, and this is the number of days for which the room was used. So total 30 days. Construct a probability distribution for the number of operating rooms in use on any given data in any given date. Show that probability distribution is valid for BPD, and find out the probability that on a given day 2 or more rooms are in use. So we can calculate probability distribution with the help of the relative frequency method. So one room was occupied for 6 days out of 30 days. That means 6 divided by 30 is 20% of the month one room was occupied. Likewise, 7 days out of 30 days, 2 rooms were occupied. That means 23.40%. And 3 rooms were occupied for 10 days out of 30 days. That means 33% of the month, 3 rooms were occupied, and 4 rooms were occupied for 7 days out of month. So that means 23.4% of the month, all 4 rooms were occupied. So sum total of all these probability is 1. So we saw the characteristic. And the probability of getting 2 or more rooms in use is nothing but probability of occupying 2 rooms plus 3 rooms plus 4 rooms. So we have to add this and this probability, that is 80%. Next is continuous random variable. CRV or continuous random variable is a random variable which can assume any numerical value in an internal, infinite or finite. In general quantities like pressure, height, mass, weight, density, volume, temperature, distance are example of CRVs, continuous random variable. So between any two continuous random variable, there are infinite number of valid values. So it can be fractional. So the previous thing was numerical value like 1, 2, 3, 4. Here it can be fractions as well. That's the basic difference. Like pressure of temperature of steam in boiler, it can be any value like in decimals, 2 decimal, 3 decimal, 4 decimal. Time in minute between two time in minutes between two successive customer assigning at a service counter can take any real value more than 0 or equal to 0. So these are the characteristics of continuous random variable. So continuous probability distribution has again following two characteristics. So probability of getting any event between A and B is always more than 0 here. And if probability of getting like A and B are equal, then probability of getting any event is always 0. So probability of getting any event out of this probability curve is 1. So if it is finite series A to B, we know ends of this series, and if we do not know end, even then it is 1 sum total, because minus infinite to plus infinite, sum total of all probability has always to be 1. So probability of any particular value of CRV must be 0. So these are some well-known probability distributions. Binomial distribution, which is also called BPD, binomial probability distribution, Poisson distribution, Poisson probability distribution, normal distribution curve, normal probability distribution curve, and standard normal distribution. So binomial distribution curve is widely used probability distribution for DRV. For a probability distribution to be classified as binomial distribution, following 4 conditions must be fulfilled. The number of observations must be fixed, so it should be finite. Each observation should be independent, second characteristic. Each observation represents one of two outcomes, success or failure. The probability of success defined by P remains same for each outcome, so equal likely probability of each outcome. Then it is called binomial distribution or BPD. Poisson distribution is another form of DPD, and it captures number of occurrence over a specified interval of time or space. It has following characteristics, like two characteristics. The probability of occurrence is the same for any two interval of equal length. That's the first characteristic of this distribution curve. And second characteristic is the occurrence or non-occurrence in any interval is independent of the occurrence or non-occurrence in any other interval. This is the comparative analysis between BPD and PPD, binomial probability distribution and Poisson probability distribution. Just remember these differences. A question may come between these two comparative analysis. So the meaning, first of all, BPD is one in which the probability of repeated number of trials are studied. However, in Poisson probability distribution, It gives count of independent event occur randomly with a given period of time. So the nature, it is biparametric. That is, it is featured by two parameters, n and p. And this is Poisson distribution is uniparametric, characteristic by single parameter. So in terms of number of trials, binomial probability distribution has a fixed number of trials. However, Poisson, it is infinite number of trials. So in terms of success probability remain constant here in this binomial. However, in case of Poisson, it's very small, infinitesimal chance of success. If we compare between mean and variance, so in case of binomial probability distribution, mean is always greater than variance. And in case of Poisson probability distribution, mean is always equal to variance. For example, coin tossing experiment, it is an example of BPD. And printing mistakes of a large book is an example of Poisson probability distribution. Sometimes examiner give example and ask which probability distribution it will link to. PPD is an approximation of BPD. In case n is very large and p is very small, where n is number of trials, like number of trials very large, and p is binomial probability of success is very small. The PPD can be reasonably approximation of BPD. So it's remember this formula, m is equal to n multiplied by p. Third type of distribution curve is called normal distribution curve. It is also called NPD in short form. So this is a type of continuous probability distribution, CPD. The previous two curves were form of or types of DPD. However, this is CPD. So these are the characteristics of normal distribution curve. Any characteristic may be helpful for exam perspective. So highest point of this curve, normal distribution curve, is always equal to mean is equal to mode at is equal to median. So mean, mode, median always be equal at highest point of this curve. This curve is always bell-shaped symmetric curve and it has zero skewness. So by default, every normal distribution curve has zero skewness. Tails of this curve extend to infinity, so they do not touch axis. And standard deviation of this curve determines flatness and width of the curve. So that means higher the standard deviation means wider and flatter curve, and which shows more variability of data. So basically, to compute probability under any CRV, you have to calculate area under these 2 points. So for example, if you want to calculate probability of happening of an event within interval of 1 standard deviation, which is like mean plus minus 1 standard deviation, this is the range. So probability of happening of for probability of getting any result out within this area is 68.3% in case of this distribution curve. These numbers are standard. Please remember these from exam perspective. And any probability of happening of any event within interval of 2 standard deviation, that is mean minus plus minus 2 standard deviation, is 95.40, and probability of happening of any event within 3 standard interval, like plus minus 3 interval from mean or middle of the curve, is 99.70%. Fourth curve is standard normal deviation, SND. It is a type of normal distribution with mean is equal to 0 and standard deviation is 1. So SND is always 0, 1. Next is sampling and sampling distribution. We quickly walk through this. Normally question doesn't come out of it, but still anything can be asked from the syllabus. So whether a sample selected represents entire population or not, it depends on two factors, which is nature of population and the method of selecting a sample. So these are the basic two sampling methods. One is probability sampling method, other one is non-probability.
So probability is also called random sampling method, and non-probability method is also called non-random or biased sampling method. Let us see each of them one by one. So there are further 4 types of sampling probability sampling methods, and elements selected in this sample have a known and equal probability of being selected. So into this sampling method, each element has equal and known probability of getting being selected. So main advantage of random sampling is that it permits generalization, that is minimized the risk of systematic biasness. However, main disadvantage is that it can be more expensive and time consuming. So these are the 4 types of probability sampling methods: simple random sampling, systematic sampling, cluster sampling, and stratified sampling. So let us understand like a little bit about each of these sub methods. The first is simple random sampling. The process of selecting a simple random sample depends on whether the population is finite or infinite. So it depends on that. If the total population is finite, there is a different process, and if it is infinite, there is a different method. So sampling from a finite population, say we have a sample space of n values, then you have to assign numbers from 1 to n to every observation of the population, and then sample of n value is selected using a table of random numbers. However, in case of infinite population, the sampling is done basis a population is considered to be infinite if observations are being generated by an ongoing process. So if data is getting generated every time, even while doing the sample, there is no fixed sample population. So that is called infinite population. For example, emergency phone calls that could come into a police station. So the sample selected from infinite population is considered to be random sampling from infinite population if following 2 conditions are met. First condition, each element selected comes from the population, number 1, and each element is selected independently. Please note that in case of simple random sampling, every member of population has an equal chance of selection. That is randomness and selection by chance. The logic behind this technique is to remove biasness while selecting these samples. Second is systematic sampling. In this method, any one random observation is selected, and then every nth, say for example third or fourth observation from the first selected observation is selected. Cluster sampling, the entire population is being divided into externally homogeneous and internally heterogeneous small clusters. Please remember these keywords: externally homogeneous and internally heterogeneous small clusters, and then one cluster is being randomly selected before the studies or sampling. Stratified sampling, here also population is subdivided into small clusters or stratas, then equal observations are randomly picked from each strata. So in previous third set of data, one cluster has been taken out. However, in this case, sample from each cluster is being taken out. So in case of cluster sampling, entire cluster is being picked. However, in case of stratified sampling, equal observations are being picked from each strata. There is a hairline difference between cluster sampling and stratified sampling. Non-probability sampling, here elements are selected as per convenience or judgment of the designer. So it's totally discretionary. Main advantage of these techniques is that these are less expensive and less time consuming. However, the disadvantage is that it is impossible to know how well the sample is representing population, because it depends on experience, and maybe it may be uh, it may be good or bad basis biasness or perception of the person who is taking out sample. So it can be of 2 types: convenience or accidental sampling, and second one is judgmental or purposive sampling. So convenience or accidental sampling is sample is being selected by a researcher based on his convenience. Samples which are most accessible to researcher are likely to be selected. This is a drawback. And judgmental, the researcher selects sample based on his own judgment or experience. This technique is normally used by media. Parameter estimation. It is a technique used to estimate a population parameter with the help of a sample parameter. So there are two types of estimates, point estimate and interval estimate. Let us understand each of them one by one. Point estimate, it involves the use of data to calculate a single value which is to serve as a best guess or best estimate of an unknown population parameter. For example, sample mean is point estimate of population mean. So mean is point estimation of a population mean. Sample proportion is point estimation of population proportion. Sample standard deviation is point estimation of sample standard deviation. So we take out a sample from population, calculate values for that sample, and we assume that the output of that small sample is equal to the larger finite or infinite population. So it is to be noted that if sample changes, the point estimate will also get changed, and thus point estimates are not 100% reliable. Interval estimate. As interval estimate is the process of calculating a range of values around the point estimate in which population parameter is expected to lie. So general form of interval estimation is equal to point estimation plus minus margin of error. So this is better calculation than point estimation. So this is important. The confidence level. So this is the point estimation and lower level of confidence limit and upper limit of confidence limit, which is called width of confidence interval. Margin of error indicates the error in two ways, by the extent of its range and by the probability of the true population parameters lying within that range. Confidence level, sometimes definition of confidence level come in exam. It is the probability with which the population parameter is likely to lie in the estimated interval. In estimation, most commonly used confidence level are 90%, 95%, and 99%. So thank you very much for watching this second last video, fourth video of statistics. If you have not subscribed this channel till now, please subscribe it and like this video so that it will reach out to more people, and I will get motivation for putting more videos on channel. Let us see what is there in last video of this session. So last video of this session, like next session, we are going to cover only small portion of the syllabus which is left, which is simple regression and correlation. Regression analysis, correlation analysis, multiple correlation coefficients, time series, index series. We will just walk through these points from the exam perspective. So see you in next session. Thank you.